Hello everyone. This week we're gonna learn about the new topic. Now let's look at what we have. Okay students, this week we're gonna learn about the Newton's law of motion. In Newton's law of motion, we have three laws, which is Newton's first law, Newton's second law, and Newton's third law. Newton's first law is also known as law of inertia, for the Newton's second law, also known as law of motion, and the third law, also known as law of interaction. Now, let's look at the details for every law. Newton's first law states that an object at rest will stay at rest and an object in motion will stay in motion at constant velocity unless acted upon by an unbalanced force. Inertia. What is inertia? Inertia is the tendency of an object to resist changes in its velocity, whether in motion or motionless. What does it mean? This means that there is a natural tendency of objects to keep on doing what they are doing. All objects resist changes in their state of motion. So, an object at rest will remain at rest and an object in motion will remain in motion. Here are the examples of the situation involving inertia. The first one is slamming hammer. The second one, pouring out tomato sauce. The third one is a person is thrown forward. And the fourth one is pulling a book. Do you know that the mass measures the inertia in our body? The more inertia a body has, the more difficult it is to start moving. It will also be more difficult to stop the body if it is originally in motion. Inertia is proportional to mass. Big masses resist changing their motion more than smaller masses. Now, let's look at for these two pictures. For the first one, a lot of inertia. The large train resists changes in motion. And the second one, a very little inertia. The small baby carriage has very little resistance to changes in motion. For the second law, state that force is equal to the mass times acceleration, which is F is equal to m times a. The net force of an object is equal to the product of its mass and acceleration. Okay, for example, we have the question like this. How much force is needed to accelerate 1,400 kilogram car of 2 meter per second per second? Okay, first one, write the formula which is F equal to m times a. Then fill in the given numbers and unit. So we are given the mass which is 1,400 kilogram and car we have 2 meter per second per second. So by using the equation we have m 1,400 kilogram times 2 meter per second per second. Then the force that we'll get is 2,800 kilogram per second, or in force we can write in a unit Newton. In Newton's second law, prove that different masses accelerate to the earth at the same rate, but with different forces. We know that objects with different masses accelerate to the ground at the same rate. Now, let's look at for the third law, which is law of interaction. In the third law, it states that when an object exerts a force on a second object, the second one exerts a force on the first that is equal and opposite in direction. Or we can say that for every action, there is an equal and opposite reaction. Here are the examples of the Newton's third law. The first one, a man walking on a floor. So there have an action and reaction. The second one, a man jumped to shore from a boat. So it also have action and reaction. Okay students, let's conclude the lessons by watching this movie.
It's a message from Mr. Paul,
New Jersey,
to y'all worldwide,
all around the world. And now, it's Newton's laws of. It's Newton's laws of. Newton's laws of. It's Newton's laws of.
Acceleration everywhere. Everywhere. Objects fall to the ground at the same rate from acceleration.
Gravity.
Air resistance makes acceleration slow, and when in free fall, gravity's forcing upon it. The centripetal force is needed to keep objects up there. Motions of circular gravity acts on objects in orbit, and horizontal vertical apart a projectile. Spinning all around the world, gravity is affecting vertical motion of projectile motion. Law states an object in motion ain't going to change, if you know what I mean, unless a force acts on and then it will go down, if you know what I mean. The second law of Isaac Newton, acceleration depends on the mass and force on the equal. An opposite reaction to the first action can be seen in three forces in pairs, and momentum, velocity, and mass will change. When objects interact, momentum may change, but the total